So for this problem, 7.38, we're given this diagram here, and so what we have is we have two masses attached to a pulley here, and they both start right here at this line labeled 0, and they're let go. And mass A, which is the heavier of the masses, begins to fall, and it falls 1.2 meters, and it's moving at a velocity of 3 meters per second. So we're also given that the mass of A plus the mass of B equals 22 kilograms. And the equations we're going to use are the kinetic energy equals 1/2 mass times velocity squared, and the potential energy equals the mass times gravity times x, which is the distance traveled. So we're going to take this equation, K1 plus U1 equals K2 plus U2. And in this problem, at the beginning, when both of them are here, not moving, their total kinetic and potential energy is 0. So now let's solve for K2. And so K2 is going to equal 1/2 times the mass of block A times the velocity of block A squared plus the mass of block B times the velocity of block B squared. So we're going to get K2 equals 1/2. And so for both of them, they're both moving at 3 meters per second. So we're going to get 3 meters per second squared, which all I did was factor that out from the inside here, times the mass of A plus the mass of B. And so crunching these numbers here, we get K2 equals 9 over 2, or 9 meters squared over 2 seconds squared times the mass of A plus the mass of B. So now let's solve for the potential energy. So we're going to get U, and so that's going to be our mass of B times gravity times the x, which in this case is 1.2 meters, plus the mass of A times gravity times negative 1.2 meters, because it's moving in the opposite direction as mass B. So what we're going to get is U2 equals the mass of B times G times 1.2 meters minus the mass of A times G times 1.2 meters. Now from here, we're going to factor out our G times 1.2 meters. And we're going to get the potential energy equals G times 1.2 meters times mass of B minus mass of A. So now we're going to take these values and we're going to plug them into this equation here. So we're going to get 0 equals 1/2, equals 9 meters squared over 2 seconds squared times the mass of A plus the mass of B, and that's going to be plus the mass of B minus the mass of A times G times 1.2, and G is 9.8, So this is gonna work out to be 11.76 meters squared over seconds squared. And so solving for this, we know what the value of MA plus MB is. That's 22. So we get 0 equals 9 meters squared over 2 seconds squared times 22 plus mass of B minus mass of A times 11.76 meters squared over seconds squared. So we're going to multiply these together and subtract them over to the other side. And what that ends up being, we're going to get negative 99 kilograms times meters squared over seconds squared equals mass of B minus mass of A times 11.76 meters squared over seconds squared. And in the next step, we're going to divide this value over here, and we're also going to multiply the whole thing by -1 to get rid of this negative here. And what that ends up being is we get 8.42 kilograms equals mass of A minus mass of B. Because we multiplied it by -1, these two will flip. So now what we're going to do is we solve for mass of B up here in terms of mass of A. So we're going to plug that in down here, and we get 8.42 kilograms equals the mass of A minus 22 minus the mass of A. And we get 8.42 kilograms equals 2 mass of A minus 22. And so solving for this, for mass of A, we're going to get 15.21 equals the mass of block A. And to solve for the mass of block B, all we're going to do is take 22 minus 15.21, and the mass of B equals 6.79 kilograms. Mass of A is also in kilograms. And so you solve the problem.